This is the video next that's going to go with our lesson about whether a set of ordered pairs is a function or not. Okay, so first thing we need to do is take care of some vocabulary words. Okay, now we're going to be talking about ordered pairs. Okay, so we know an ordered pair is an XY combination of numbers, right? Now, we also have some other words to describe X and Y, okay? So right here, my next one, my X coordinate. Sometimes they will just say X coordinate, but then sometimes they'll use some other words. We might call it the input. We'll go back to elementary school, that's what they called it, the input, okay? They might call it the independent variable. Okay, it might be called your independent variable. Another word for it is domain. So when we are talking about ordered pairs and functions over the next few months, we're going to use these different vocabulary words at a time to refer to X coordinate: input, our independent variable, or our domain. Now we have some special names also for the Y coordinate. Okay, well, let's just kind of pair them up here. If X is input, the Y coordinate will be output. Okay, your X coordinate is called the independent variable. Let me just put that right there. Okay, for your Y, it is the dependent. Okay, and we call sometimes X domain. If we're using X domain to mean X, then what we're going to use to mean Y is range. Okay, so when we're talking about Y coordinates, they might say output, they might say your dependent variable, and they might say your range. Okay, now we got two more vocabulary words to put in here. The next one is relation. Okay, a relation is any set of ordered pairs. Okay, so it's more than one ordered pair. Okay, this can be done in a list, a table, or we might see it as a graph. Okay, but it's a set of ordered pairs. Okay, now our next word is function. Okay, a function is a set of ordered pairs that every input only has one output. Okay, so a function is a relation because it is a set of ordered pairs, but they're a special case of relations because it means every input in the set has only one output. Okay, now our job in this lesson is to take a relation, a set of ordered pairs, and decide whether it is a function or not. Okay, does every input have only one output? Now, there are two ways to do this. Okay, the first way is called the mapping method. Okay, mapping method. Now, what do I mean by mapping method? Okay, this is a way to show the work to decide if a relation, that set of ordered pairs, is a function or not. Okay, so it's just a way to show you work, and everybody around the world can read it and know exactly what you're doing. Okay, now we're going to work two examples, one that is and one that isn't. Okay, so for example 1, I'm going to have a set of ordered pairs. I've got a curly bracket. Those curly brackets means you've got a set of something or a group of something that go together, that hang out like friends. Okay, my first ordered pair is 1, 3. Put a comma right there between them. They're a list. I have 3, 5. Put another comma right there, and then I've got 2, 2. Now the question is this a function? Does this list of numbers, every input has only one output? Okay, so what we're going to do is we're going to show the mapping method for this. Now the mapping method, I'm going to start with 2 bubbles, and I'm going to make them teeny tiny. I'm going to label the first bubble X and the second bubble Y. Now, what I'm going to do in this bubble is I'm going to list each individual different value for X that I have. So my X coordinate here is 1, here it is 3, here it is 2. So I'm going to do 1, 3, 2. Okay. Now in the Y bubble, I'm going to do the exact same thing. I'm going to look at my ordered pairs and I'm going to write down my Y coordinates. I'm going to write down 3, 5, 2. So 3, 5, and 2. Now, the next part of the mapping method is that you connect using an arrow every input with its output. Now look right here. 1 and 3 is an ordered pair. So I'm going to take an arrow and go straight over. And I'm going to put an arrow right there going to 3. In this middle point, 3 goes to 5. So I'm going to do just like that. And then on this one right here, 2, 2, that means 2 is going to go with 2. Now, here's our catch. To be a function, make a little note right here. To be a function, every X can only have one arrow. Okay? The first X right here has only one arrow. The 3 right here has only one arrow. The 2 right here has only one arrow. So if I know that, I would say right here that that is a big old yes. That is a function. Okay, well that looks simple. Now let's do another example. Our next example is going to be one that's not a function, so we'll see how they're different. Okay, so example 2 right here. I'm going to have another set of ordered pair, my little curly brackets. Remember, the curly brackets just means that all this is a set or a group together. Like if you were my classroom, I could put all your names in there because you're my class. You're a set of students that I have. Okay, so I'm going to have for my first ordered pair 1, 4. Then for my second ordered pair, I'm going to have 3, 2. And for my third ordered pair, I'm going to have 3, 7. And close my set. Okay, now I'm going to do the same thing I did before. I'm going to set up my bubbles. So here's my bubble for X. Here's my bubble for Y. How many lines should I give my bubble? Well, 1 line for each ordered pair. Okay, now here's a catch. When we are writing, make a little note right here. The numbers, we do not repeat. Trying to squeeze it in there. So when I'm writing down my numbers here, I do not repeat them. Okay, so if I look right here, I've got 1, 3, and 3. I'm only going to write that 3 one time. So I've got 1 and 3. Now over here in the Y, I've got a 4, a 2, and a 7. They don't repeat, so I'm going to write each one 4, 2, and 7. Now I'm going to do just like I did up here. I'm going to draw those arrows. Okay, so 1 is paired up with 4. So an arrow going from 1 to 4. Now my 3 right here, sorry, my 3 right here goes with 2. So I'm going to put an arrow right there. Okay. Now right here, my 3 and my 7, that 3 is also going to go with the 7. Now notice my 3 right here has 2 separate arrows. Okay, since it has more than 1 arrow coming from it, that is a big old no, not a function. Why? Because the 3 has 2 arrows. Remember, every X can only have 1 arrow to be a function. Okay. Now, there is another way to decide whether you have a function or not. And this is called the vertical line test. So let me put my paper right here. Now, so we're going to call this part 2. The mapping works really well when you have ordered pairs. But sometimes it's not just ordered pairs. Sometimes it is a graph. Okay, now what do I mean by that? Let's take a look right here. Give myself a couple of axes. I'm going to do 4 of them. You can kind of see some different examples. All right, so might have just a diagonal line, just a good old line on the graph paper. We've done those in 6th and 7th grade at times with different things. I could have something that has kind of a U shape. Okay. What if I have something that is a C shape? Okay. And what if I had something that was almost S-shaped? Okay, they're curves, they're not lines, they're curves. Okay, so I have these 4 graphs. Now my question is, are these functions? Okay, are they functions? Now, here's the catch. When you do the vertical line test, what you are going to do, and I'm going to use my pencil right here as a demo model. I'm going to roll my pencil right across my graph. If I find any point in time, look right here, if I find any point in time that it crosses that graph more than once, now notice my pencil's vertical. It's called a vertical line test. You got to keep your pencil vertical, okay? Not slanted or sideways. Got to be vertical. But I'm going to roll this vertical line all the way around my paper. If I can find a spot somewhere, anywhere in that graph, say like right here and right here, that vertical line is going to cross that graph in 2 spots or more, that is no, not a function. Okay, now let's get back up here. What does do this while right here? Whoop, whoop, whoop. Rolling my vertical line across, look right there. It fails it because there's 1, 2, 3. That's more than one, isn't it? 1, 2, 3 spots that it touches. So that's a no. It is not a function. It's a relation, but not a function. Okay? Well, now look up here at the line. If I roll my pencil, my vertical line across the picture, everywhere I stop it, it is only touching that line in one spot. So I would say, yes, this is a function. Look right here. Yeah, on my little U. That U shape is actually called a parabola. So I'm going down my parabola with my vertical line, and it's never touching in more than one spot, is it? Always just one spot. So that is also a yes. Now, vertical line test works great when you have a graph of something to decide whether it's a relation or a function. Now, again, do I want to put a little note down here at the bottom that kind of help me remember this? Okay. Let's see. Grab another color. Do red. Okay, right here. Vertical line touches only once. Okay. Right here, what happens? Vertical line touches more than once. Now, our lesson today, again, is just deciding whether something is a function or not a function. Later lessons will have us working with, well, what do we do with it once we know yes or no? Okay, make sure you get these copied into your interactive notebook, and then you can return to Canvas and do your assignment.